Now, our first example is to write 50 million in scientific notation. And to achieve this, we know that in any number like this, there is a decimal point at the end of it. That's why sometimes it is possible to have 0.00 at the end of this number. But then because it doesn't hold any value, so it is mostly ignored. And because it is being ignored, it appears as if there is no decimal point here. But there's actually a decimal point after every whole number. So knowing where our decimal point is on the right. The decimal point being on the right should give you an indication of the sign of your exponent. So our exponent is going to be positive because the decimal point is on the right, which is going to be moved to the left. So we are going to move our decimal point from the right to the left and count the number of steps. So we are moving 1, 2, 3, 4, 5, 6, 7. So the decimal points have been moved here. Now, why are we stopping here? We are stopping here because at this point, we are getting our coefficient to be between 0 and 10 or from 1 to 9. So 5, it's an appropriate decimal, an appropriate coefficient. So our answer simply is going to be 5 times 10 exponent 7. 5 is our coefficient, and this is our power of 10, and 7 is telling us the number of steps we took to move our decimal point behind the coefficient. So this value is in scientific notation. If that is easy, then let's look at our next example. We are converting 0.0036 to scientific notation. Here, our decimal point is on the left. Our decimal point on the left gives an indication that the exponent is going to be negative. So the moment you see the value, you know exactly what the exponent is going to be. Our decimal point on the left shows that our exponent is going to be a negative value, and this shows that it is a very small value. When it is on the right, it is big. When it is on the left, it is small. So knowing you are going to get a negative value, it's a plus. So we are going to move our decimal place from the left side to the right side and count the steps. So we are moving 1, 2, 3, 4. So we are getting 3.6. Why 3.6 and why are we stopping here? Because at this point, I'll get 3 points, which gives me a coefficient which is between 0 and 10 or from 1 to 9. If I move to this point, if I move here, I would get 36. 36 is greater than 9 and it will not make my answer scientific notation. So I end here and get 3.6. And 3.6, this value is less than 9. So my coefficient is correct. So I need my power of 10 times 10. How many steps did I move? I moved 1, 2, 3, 4 steps. 4 steps, and I moved from the left to the right. So my exponent is negative. I've also converted this into scientific notation. Always make sure that the coefficient is always less than 9. So this is my last example. This is the simplest approach, but remember I said that when the decimal point is on the left or when it is a negative exponent, it can be written as is equal to 9 over, and this can also be written as 9 over 10 exponent 5, and apply the law of indices here, which is 9 times 10 exponent minus 5. This will also give you the same answer, but this one looks quite longer but very easy to understand. Likewise, if it's a positive exponent, for instance, if it was 9, let's say 9,000, this can also be written as 9 times, when it is negative, you said you multiply 9 times 10, 9 times 1,000. And this can also be written as 9 times 10 exponent 3. This gives us a positive power and this gives us a negative power. You can also use this method, just that the first approach where you move the decimal places is much easier than this one. As we said in our explanation, scientific notations are used to summarize values. But then sometimes you get to a point that when you are writing, though you summarized it, but then when you write, for example, 5 times 10 exponent negative 5 grams, though we have simplified this value, but yet pronouncing it becomes so much of a problem. So scientists decided to use something we call prefixes to summarize and abbreviate this value and make pronouncing it or writing it or communicating it much easier after the scientific notation. And that is what we are going to look at next. For instance, 5 times 10 exponent minus 5 or times 5 times 10 raised to the power minus 5 can be converted to milligram. So what is the milli? Where does it come from? If you notice, it is a small it's a group of letters that are written in front of a unit or an SI unit. And because it comes before the unit, we call it a prefix. That is the main reason why you call it a prefix. It comes before the unit. If in English, in front is prefix, after is suffix or something like that. So we are going to look at what these prefixes are. So with this example, our 5 times 10 raised to the power negative 5 can simply be written as 0.05 milligrams. That being said, what is a prefix? And this milligram thing, what is it at all? Prefix is simply a word which is written before you need to simplify them, as simple as that, to make it look simpler. We have several of these prefixes here, several of them. The exponent determines the value. So the first one we have iota, which is 10 exponent 24, zeta 10 exponent 21, hexa 10 exponent 18, peta exponent 15, tera exponent 12, giga exponent 9, mega exponent 6, kilo exponent 3, hecto exponent 2, deca exponent 1. 10 exponent 0 do not have a name. It is not a prefix, does not have a prefix. 10 exponent minus 1 is deci, negative 2 is centi, negative 3 milli, negative 6 micro, negative 9 nano, negative 12 pico, negative 15 femto, negative 18 atto, negative 21 zepto, and negative 24 yocto. Take note of the signs, because these signs appear in front of the unit. For instance, if you are having 2000, this can be written in scientific notation as, so you can see that 2000 can be written as 2 times 10 exponent 3 meters. So 2000 meters equals to 2 times 10 exponent 3 meters. 10 exponent 3 has a prefix we call kilo. So in place of 10 exponent 3, we can just write kilo, K, to represent this value. So we are going to have 2 kilometer. Instead of saying 2 times 10 raised to the power 3 meters or 2 times 10 exponent 3 meters, you can just say 2 kilometers. As simple as that. So if we check this value, 2 times 10 exponent 3 meters and 2 kilometers, they are the same, because K here is the same as what is here. So I can even pronounce this 2 kilometer, 2 kilometer. So we have used a prefix in place of a power of 10, which indicate that we have summarized the value much further. Likewise, if you have 0.07 meters, I'm still using meters. This can also be written as, let me go the simpler way. If I move the decimal point from the left, I'm going to get a negative exponent. So the number of times I move determine the exponent I get. So I'm moving from the left, I move 1, 2. So I'm going to get 7.7 times 10 exponent, I move twice and I move from the left, so I'm going to get -2 meters. 10 exponent -2 can be represented by a prefix, and that prefix is centi. So 10 exponent -2 is centi. So in place of 10 exponent -2, I will just write C to represent the whole of this. So this is also going to be equal to 7 cm, 7 centimeters. So instead of saying 7 times 10 exponent -2 meters or 7 times 10 raised to the power -2 meters. So make sure to get all these into memory. If you can't, there are some that normally appear at this level. There are some that normally appear regularly in our work. For instance, tera is a little bit popular, giga, mega, kilo, we've already done something on kilo, hecto too is there. Then on the other side, we have deci. Mostly in chemistry, we find deci there. We have centi, milli, micro, nano, pico, and sometimes femto. These are also prefixes that appear regularly. So if anything at all, you should know these prefixes, their symbols, and their values. So now that we know the prefixes and their values, let's look at our first example. Now, example 1, the distance between Earth and the Moon is about 384 million meters. Now, write this figure in scientific notation. And B, use an appropriate prefix to represent this value. Now, how do you go by this? Now, 384 million can be written as, now remember we have this, I said we have a decimal point here. So if I'm moving the decimal point from the right, I'm going to get a positive exponent. So I count the number of times I move in order to get a number or a coefficient that is either 1 or from 1 to 9. So I move from here, I move 1, 2, 3, 4, 5, 6, 7, 8. Now at this point I have a coefficient that falls within the range 0 and 10. So 1 to 9. This 3 is a value that falls within that range. So I'm going to get this in scientific notation as 3.84 times 10 exponent. How many steps did we move? 1, 2, 3, 4, 5, 6, 7, 8. So we are going to have our exponent to be 8. So now we have our answer in scientific notation. Or you can also say that 384 million is equal to 384 times 1 million. So this is going to give us 384 times 10 exponent. How many zeros do we have? 6. But is this scientific notation? No, this is not scientific notation because 384 is greater than 9. We want this value to be either from 1 to 9. We can't have a value that is greater than 9. So what do? We now convert this small one into our scientific notation. So this is going to give us, let me continue on the other side. This is going to give us 3. Okay, so if I'm moving the decimal point from here, I'm moving twice. So 1, 2 here. Good. So I'm getting 3.84 times 10 exponent 2 times 10 exponent 6. So this is for only the underlined part. So from the law of indices, since we have 10 here and 10 here, we just add the powers. So you are going to get 3.84 times 10 exponent 8, and we have the same answer. You see how long this one looks, but this one looks much easier. Now the next question said we should use an appropriate prefix to represent this value. Now we are writing a prefix for 10 exponent 8. So you have 3.84 times 10 exponent 8 equals. Now let's go back to our prefix and identify something. You notice that most of the powers are multiples of 3. So from 0, 1, 2, the rest is just multiples of 3. When you go down, it's the same thing. -1, -1, -2, -3, and from here is just multiple of 3. 3, 6, 9, 12 onwards. So just have this in mind. So anytime you are given a question such as this, what you need to do is that you are going to split this power such that you can get a value that have a prefix. Now 10 power 8 do not have a prefix. So you are going to split this in such a way that we can get a prefix out of this. So the next thing is to find or use an appropriate prefix to represent this value. So our answer is 3.84 times 10 exponent 8 meters. This was the answer we had in A. So we are going to write a prefix for this. Now you notice that back here, all the powers of 10 or the values of prefix have powers that are multiples of 3. So now let's check something from here. Now you notice that all the powers of 10 or the values of the prefixes have powers that are multiples of 3 except 1 and 2. So from 1 and 2 we have the powers to be multiples of 3. 3, 6, 9, 12 onwards. Likewise, if you come down here, the submultiples, we have -1, -2. Then after that we have multiples of 3, 3, 6, 9, 12 downwards. So anytime you have a question like this, you are going to split the power such that you get a power that can be represented by a prefix. 10 exponent 8 do not have a prefix. So you are going to split this such that we get a prefix. So with 10 exponent 8, we have two options. So we can have for 8, we can have 2 and 6. We can have 3 and 3. I think these two are the best you can have because here you have a prefix. This can be a prefix. This can be a prefix. This can also be a prefix. But which one is more appropriate? Now, if you pick this one, you can get a prefix all right, but then you are still going to get a larger value, which will make your struggle to summarize your value useless. So I think the most appropriate is 2 and 6. Now choosing 2 and 6, let's come here. So we are going to get 3.84 times 10 exponent 2 times 10 exponent 6 meters. Now, which of these two have a prefix? Power 2 have a prefix, power 6 have a prefix. Which of these do you think we should give a prefix because we can't have two prefixes here? Centi, whatever meter. We can have only one prefix. So which one should we take? We are taking this because if we take 10 power 2, we are still going to get a bigger value, which make our struggle to summarize the value useless. So 10 exponent 6, let's refer and see. 10 exponent 6, what is the prefix? It's what? Mega. 10 exponent 6 is mega and the symbol is capital M. So in place of 10 exponent 6, I'm going to write, so I have 3.84 times 10 exponent 2 mega meter. Now, you notice that we have 10 exponent 2 here. The reason we are bringing mega, the prefix, is to make it more simpler, running away from the scientific notation. But we still have an exponent here. If you don't do away with this, what we are doing will be a cos 90 job. So with this, we just multiply our value with this small exponent and it will still keep the numbers we are having here. So if you multiply 3.84 times 10 exponent 2, we are going to get 384 mega meter. So you notice how a big value was summarized here and now abbreviated as simple as 384 megameter.